Yes.
Tell me about end behavior.
It's like the ending of like a graph, like where like the points would go beyond the graph, like what you see.
And that's true, exactly. Now, what I want you to think of it, whoops. What I want you to do is I want you to think of it as being in terms of what happens to the y's. As the x's get bigger and bigger. And what happens to the y's as the x's get smaller? And what I like about this notation is that's exactly what this says. So Logan, tell me what I can do about figuring out the end behavior of this guy. What am I looking at? What am I looking for?
Like the aren't we looking at like the first number?
We're looking for the leading coefficient. Now, very often it's the first one. In this case, it is the first one. But Logan, is it always going to be the first one?
No.
No. So we got to make sure we don't just look at the first one, and it's really rough because when we say leading, in a lot of times it is the first guy. But in this case, it is the guy with the biggest power. The term with the biggest power is definitely first. So the coefficient is negative. What does that tell me about the end behavior?
That's negative.
What's negative?
Going down.
When?
When it's positive.
What's positive?
Infinity.
So
Like
I want you to think about this. We've got two choices. Either the x's are getting bigger or the x's are getting smaller. And it gives you both those choices right here. So which one does it tell us? It's going down when? When the x's are getting smaller or when the x's are getting bigger?
When the x's are getting bigger.
Exactly. So this is going to be negative. Now, the next thing I look at is the exponent of the leading coefficient or the leading term. And if it's odd, then the other one's different. And if it's even, the other one's the same. So what's the other one going to be, Logan?
It's going to be positive infinity.
Yep. Colin, tell me about number 2.
The leading is 5x by power 4.
Awesome. So now, what do I know?
It's up for the first one.
And say it. As the x's get bigger,
Y gets bigger.
the y gets bigger. Because that's the way I want you to remember it. Now, what does the exponent tell you, Colin?
Whether it's the opposite or the same.
Exactly. Is it going to be the same or opposite?
The same.
So this one also is going to get bigger when the x's get smaller. Jake, tell me about number 3.
The leading coefficient is negative x to the 5th.
Awesome. Notice how it's not first. So what does that negative sign tell me?
That when x gets towards positive infinity, it goes down.
And I want you to notice how sometimes it's first and sometimes it's second. You actually have to read it. So that means as the x's get bigger, the y's get smaller. Now, what does this tell me?
That it's the opposite.
So the other one has to be different. That means as the x's get smaller, the y's get bigger. Kayla, tell me about this last one.
It's going to be as that y gets smaller as x gets smaller. This is down, and behavior.
Y gets smaller as x's get bigger. And then what's the other one going to be?
It's going to be y gets smaller as well.
Y is also going to get smaller as the x's get smaller. Don't just look at it, make sure you're reading it. But when you're reading it, that's awesome, thank you, by the way. It tells you exactly what you're trying to figure out. What happens to the y's as the x's get bigger? What happens to the y's as the x's get smaller? If I write up, down, what I'm telling you is, as the x's get smaller, the y's go up. And as the x's get bigger, the y's go down. The first one tells me what happens as the x's get smaller, and the second one tells me what happens as the x's get bigger. That won't ever change. If you ever hear someone talk about M behavior and they say down, up, that first down is about what happens as the x's get smaller. And when I'm drawing this line, think of it as a number line. Here's 0, and obviously these are getting smaller and smaller. And if this was up, well, now my x's are getting bigger and bigger. As the x's get bigger, my y's get bigger. But that's all there is to that. So let's take a look at something new. By the way, are there any questions? Anyone got any questions about that?
Yes, I'm kind of really confused, like on the whole, looking at the equation and telling which one, like, is going to be positive and negative. Like, it's just really confusing me.
All right, so doesn't matter how many terms there are. The only one we care about is the guy with the biggest exponent. So look at number 4. Which one has the biggest exponent?
2x to the 4th power.
Exactly. Now, don't forget, it's actually a negative 2x.
Negative,
right?
negative 2x.
All right, now, there's two things. The negative sign, or whatever this is positive or negative, that tells me what happens as the x's go up. What happens as the x's go up?
It gets smaller.
It gets smaller. And you see how this says x's go up? And I'm just going to put it down here. Now, the thing is that negative sign or that positive sign, it only tells you what happens as the x's go up. The exponent tells you whether the other one is the same or different. Now, if it's even, they're the same. And if it's odd, they're different. So in this case, it's even. So the other one also has to be -8 or negative infinity. Now, what people get confused about is remembering. So does the sign tell me which gets bigger or whatever? Or is it odd or even? And I want you to think about this. Don't get me wrong. It's completely possible for an exponent to be negative. But what's going to happen most often, especially in this class and in the polynomials we're going to deal with, these exponents are always going to be positive. So the question about the exponents is not whether they're positive or negative. The question about the exponent, and again, only the one, is whether it's odd or even. Now, coefficients, they can be positive or negative. And so that's how I tell. Now, the thing is, I always look at the coefficient first, because number one, it's the first thing I see. And that only tells me what happens as the x's get bigger. So this guy is positive. It's the biggest exponent. So I know that's what I'm looking at. And it's the only one I care about. So if that's positive, that means as the x's get bigger, then these also, the y's are also going to get bigger. This exponent is even, so that means that the other one has to be the same. Does that make sense? Is that better? So it
Yes,
is
thank you.
something, it's something to remember. The coefficient tells you what happens as the x's get bigger with the end behavior. The exponent tells you whether the other one is going to be odd or is going to be different or the same. Is that okay?
Yes.
Awesome. Anyone else got a question? All right, let's take a look then. In these, in the last class, you remember how we solved quadratics. And basically what we did was we factored them. And when we factored them, we found out, well, maybe it looked like this. If we factored them, maybe it just looked like this. 2 factors. And then what we did was, if we're solving them, we're finding out where y equals 0. Remember we said we were finding the x-intercepts. The x-intercepts are when y equals 0. So then what I would do is I would make each one equal to 0. And then I would solve them. And one of my answers would have been 9, and the other answer would have been -12. Now, the only difference between this, and again, you've already had units and all kinds of time spent on quadratics. In this case, what's going to happen is we're going to be talking about polynomials, so they're probably going to have more factors than just the 2. And so in this case, I can add this third one of x minus 7 equals 0, and then x is going to equal 7. If you were to graph this exactly the way it is, except for the 0, if you graphed y equals in Desmos, what you would find is there's an x-intercept at 7, an x-intercept at -12, and an x-intercept at 9. So one of the things that you can do is you can graph this, but if it's written this way, it's a whole lot easier to find the x-intercepts if you know what's going on. Now, the fundamental theorem of algebra says that whatever the degree is, there should be that many zeros or x-intercepts, or not x-intercepts, roots or zeros. They don't always have to be x-intercepts, and we'll talk about that in a second. They have to have zeros. They have to have that number. And if you take a look at this case, if I would have multiplied all this together, x times x times x, this would have been x to the third plus a bunch of other stuff, but the biggest exponent would have been x to the third. And do you notice how there are 3 zeros? 3 things that can make it equal to 0. Now, if you take a look at this one, how would I break this apart? Isabel? We're going to do the same kind of thing you just did, only we're going to break this apart. What would the zeros or what would the zeros be?
I'm confused.
Well, think about it. How did I find this factor here? What did I do to make it equal to 0? So here, think about it like this. What if I gave you, I've got 2 things multiplied together that equal 0. One or both of these things must be 0 in order to multiply them together and have it equal 0. In this case, I've got 1, 2, 3 things multiplied together. And they, if we're trying to find the zeros, must equal 0. So that means that must equal 0, that must equal 0, and that must equal 0. So now what I got to do is figure out what those are. So all I'm going to do is take each one of these guys and I'm going to separate them. And I'm going to take this first factor and I'm going to say x to the third equals 0. And then I'm going to take the next one and I'm going to say x plus 4 squared equals 0. And I'm going to take the last one and I'm going to say x plus 5 equals 0. Now, if I solve this, Isabel, what would I get? What would x equal?
-5.
Awesome. That's where one of my zeros is. Now, if you take a look at this, x plus 4 squared, Isabel, doesn't that mean x plus 4 times x plus 4?
Mm-hmm.
So that means this could equal 0 or this could equal 0. What would the x be?
-4.
Exactly,
Yeah.
right? Because if I wrote x plus 4 equals 0, whoops, if I wrote x plus 4 equals 0, when I took it away, I would get x equals -4, right?
Mm-hmm.
Now, tell me about the x plus 5. Oh, we did that one already. Tell me about the x to the third.
-x3.
Isn't that the same as x times x times x equals 0?
Yeah.
That means x could equal 0, right?
Uh-huh.
What is 0 to the third power?
0.
And see, I'm looking for x's that are going to make it equal to 0. That's why we call them zeros. Now, here's the trick. I want you to notice that if I take x to the third times x squared, that's going to be x to the fifth. And x to the fifth times another x, that's going to be x to the sixth. And I just said that the rules are that if the degree of the polynomial is 6, then there have to be that many zeros. And we only actually have 3. And the reason for that is because there's something called multiplicity. And that's when a 0 happens more than once. Take a look at this one. Do you see where it's x times x times x? Well, that x happened 3 times. That factor resulted in a 0 of x equals 0. But it happened 3 times. So what we would say is it has a multiplicity of 3. And you take a look at this -4. How many times did the factor happen that created this -4? It happened
2.
twice. So that means we would say it's got a multiplicity of 2. And then take a look at the factor that made me a 0 of -5. It only happened once. We would say it's got a multiplicity of 1. Now, if you add those together, you'll get 6. So what's going to happen is with the polynomials we're talking about, very often they're going to have zeros and they're going to have multiplicities. So Cooper, tell me about this next one. Tell me about this. I want to know what the zeros are and what their multiplicities are. Each factor is going to create a 0. What does x have to be so the whole thing ends up equaling 0?
0.
You can think about it. What is 0 times 0 minus 1 times 0 plus 4? It's going to equal 0 because one of these guys is a 0. So my first one is a 0. Now, take a look at this next one. It says x minus 1. So what's going to make that equal to 0? What would x have to be so that factor equals 0?
1.
And so it's going to be a 1. Now, how many times did that factor happen?
Twice.
So we would say it's got a multiplicity of 2. And then look at the last one. What would x have to be so that when I add it to 4, it equals 0?
-4.
And that's going to be the 0. And then how many times did that happen?
3. 3 times.
Because it's x plus 4 times x plus 4 times x plus 4. We would say it's got a multiplicity of 3. This first one had a multiplicity of 1. The second one had a multiplicity of 2. And the third one had a multiplicity of 3. So tell me now, Jalen, what would you tell me about this one? What do you think the zeros are?
-2 and 6.
So -2 and 6. Now, what are their multiplicities? How many times did that one happen?
1.
How many times did that one happen?
1.
All right, now, keep in mind, every factor can result in the whole thing equaling 0. So what would x have to be so x squared equals 0?
0.
That's the other 0. Now, how many times did that happen?
Twice.
We would say it's got a multiplicity of 2. So if it's written in factored form, it's pretty easy to figure out. Now, again, if you would have graphed any of these, then you would have found out where they cross the x-axis, then it's going to have, the x-intercepts are going to be zeros. Now, this one right here is a little bit weird. This is a cube. And I don't know if you recall difference of 2 squares. If I had x squared minus 25, and if I asked you to factor it, you could go like this. Put an x and an x, make 1 plus, make 1 minus, take the square root of that. Now, it's called an algorithm. It's just a rule that always works. It's a recipe. It's something that we do when we're doing difference of 2 squares. And it's easier, it makes factoring easier. This is a difference of 2 cubes. This is a perfect cube, and this is a perfect cube. Now, the rule for it is a little bit more complicated, but at the end of the day, it's just a rule. If I want to factor 2 things that are perfect cubes, then all I'm going to do is take the first cube root. So the cube root of a to the third is a. I'm going to keep the sign. I'm going to take the second one and cube root it. So that's going to be b. And then I'm going to multiply it times whatever a is squared. I'm going to change the sign, so it'll be positive. I'm going to take the a and the b and multiply it together. And then I'm going to take the last one and I'm going to square it. So if I can remember this pattern that's always true, and I recognize that the 2 things are perfect cubes, this is a perfect cube and this is a perfect cube. So then what I would do is say, what's the cube root of x to the third? Well, it's x. And this is a minus sign, so I keep the minus sign. And what's the cube root of 8? It's 2. And then what I'm going to do is I'm going to take this first term and I'm going to square it. That becomes x squared. And then I'm going to change the sign. So now it's going to be plus. And then I'm going to multiply the 2 things together. It'll be 2x. And then I'm going to square the last thing. That'll be that. If I were to multiply these 2 together, I would get x to the third minus 8. And again, this pattern always holds true. Now, the thing is, though, if you were to graph this, what you would find is, well, in fact, maybe we can. Let me tell you what we will. How about if I do that? X to the third minus 8. There, can you see that? X to the third minus 8. Do you notice how it only actually crosses the x-axis once? This down here, this is also another place where it can end up being a 0. If I were to solve this, what would happen is it doesn't factor. And so I would end up using the quadratic formula. And what would happen is I would end up with the square root, and it's going to have some kind of negative number in it. And that means that it's going to be I square root of whatever. Do you remember complex numbers and whatever? It'll be 3 plus or minus something I. I don't know what the number will be inside. If you remember, complex numbers, they aren't on the x-axis. They're either floating around up above or floating down below. In this case, it has, because remember, we said that if it's got a power of 3, it has to have 3 zeros. Well, it's got 1 here and 2 here. They're complex zeros. And again, think back to when you were doing your quadratics in Math 2, and sometimes you had complex solutions. If you would have graphed them, those complex solutions wouldn't have been x-intercepts. There's always a +1 and a -1 because of the way we look at this quadratic formula. It's always going to be some positive number, plus or minus, and then this thing with an I on it. And you don't got too worried about that. Just know that that's a thing. Now, mousey. You do recall factor by grouping. We can factor by grouping when there is not a greatest common factor for everything. In this case, I can't factor the whole thing, but if I look at this right here, I can identify a greatest common factor. The first greatest common factor, I look at it, I say, oh, they both have an x squared. So then when I divide that out, x to the third divided by x squared is going to be x. 5x squared divided by x squared is going to be 5. And that ends up like that. And then if you recall, when you're factoring by grouping, you look at the second set. And what you want to have happen is you want the thing in the parentheses to be the same. So again, I'm going to try factoring out the greatest common factor. If I take out a -4, well, -4x divided by -4 is positive x. I like that because this other guy is positive. And then -20 divided by -4 is positive 5. So then what happens is that I would need to go ahead and take the factor that's the same, and that'll be one of my factors. And then I'll take the other two and put them together. Now, at the end of the day, this x squared minus 4 is factored into x plus 2, x minus 2. This is still going to be x plus 5. My x-intercepts are going to be -5, -2, and +2. And like I said, if you just graph it, you'll be able to see the x-intercepts, and you can find that too. So what I want you to do is I want you to try factoring by grouping here, number 7. Look at the first 2 terms, identify greatest common factor, look at the second 2 terms, and then try to do that. I'll give you a second to try it.
I have a question.
Yes,
Where did the x squared minus 4 come from
x squared minus 4. Oh,
on number 6?
okay. So take a look here. So you see where the x plus 5 came from, right? It's the one that's the same, right? Say yes.
Yes.
Now, look at the other 2 things that we didn't have. Do you see how there's an x minus 4 here?
Oh,
That
okay.
is where it'll come from. So what'll happen is you'll end up with typically 2 factors. One of them will be in the parentheses and it'll be written twice. And then the other one will be this side part. Does that make sense?
Yeah.
You remember doing that last year? You guys did do this last year, didn't you? Say yes or no.
Kinda.
You do remember? No, we don't remember. Maybe you guys didn't do it. Carly, tell me about this one. What's the greatest common factor?
I took out -x squared.
Okay, now do me a favor. Let's try to keep it positive, but I'm going to take x squared. Now what? What's 2x to the third divided by x squared?
2x.
Yes. Now, what's -x squared divided by x squared?
-1.
Exactly. Now let's look at the second one. What's the greatest common factor between these two? So then I'm going to take out a 3. What's 6x divided by 3?
2x.
And then what's 3 divided by 3?
1.
But wait a minute here, hang on. 6x.
Wouldn't it be a -3?
Yeah, we got to make it a -3, right? Thank you. What's 6x divided by -3? That's going to be
Negative
2x. And then 3 divided by -3, that's going to be a -1. Now, do you see how one of the factors has been parentheses and it's written twice? That's one of our factors. And then the other factor is going to be the other things put together. So that'll be x squared minus 3. Now, if I were to solve this, again, making it equal to 0, if I make 2x minus 1 equal to 0, add the 1, and then it's going to be x is equal to 1/2. And see, that's where you have to be careful, because sometimes people just say, always take the opposite, which taking the opposite does work a lot, but sometimes you actually have to make it equal to 0. Same thing with this one, x squared minus 3 equals 0. X squared equals 3. And then when I square root both sides, x is going to equal positive or negative square root of 3. This has got a power of 3. It should have 3 zeros. There's one of them, and then the other one is positive square root of 3, and the other one's negative square root of 3. There's 3 altogether. 3 numbers that if I plug it into the original is going to cause it to equal 0. Or if I graph it, cause it to be on the x-axis. Now, I want to take a look at one more thing. Actually, 2 more things, but this is pretty easy. All I'm going to do now is reverse the process. If these are the zeros, what are the factors that could have made them? So, Calissa. I want you to think back to what we did a second ago. Calissa, you with me? Calissa, you with me? How about you, Chelsea? Are you with me?
Yeah, sorry, hold on. I'm talking to my sister.
Take
Which
a look.
one? The first one?
So what would the 0 be?
Oh, did someone?
What would the 0 be?
Me or someone else?
You, Chelsea.
Um,
What would the
maybe
0
9.
be? It's going to equal 9. All right. Now, what's going to happen is we're going to reverse this process. I'm going to give you the 0, and I want you to make up the factor that's going to cause it. Does that make sense? So watch. Come on, mousy. So here, instead of you finding the 0, I'm giving you the 0. What would the factor be that would make it x equals 0 would be a -1? What should I put in here? X what?
Plus 1.
If I put in a +1, and think about it, if you were to find, if I said, what are the zeros, you would say it's a -1. So Chelsea, what about the next one? What would this be?
-2,
Exactly. And then what about the last one?
-3.
All we're going to do is find the opposites, right? Olivia,
Yeah.
tell me about this one. If I give you the zeros, how can you make a function that would cause those zeros to happen? What would the factors
X
be?
minus 3. X minus 3. X minus 1.
And in fact, do you see how this x minus 3 is written twice? You probably would have done this, except for I wrote it already. Because that's the same thing, it's squared, right? How many times did that 0 happen? It happened twice. So I could just do this instead of writing that, right? So here's a tough one. Neela, here's a tough one. What's going to give me a 0 of 0?
Is it just x?
Exactly. And if you want to think of it, just like the other ones, you know, I did a plus or minus. Well, what if I wrote x minus 0? Well, isn't that the same thing as 0? So yeah, if I wrote y equals x, now Neela, how many times did that guy happen?
Twice.
So I'm going to square it because that's the same thing as x times x, right? Now, take a look at this one. This is going to be a factor. Now, the thing is, I want you to think about this. When we had a 3, we just did the opposite. In this case, there's more going on. We divided by 3. So what am I going to do to the x, Neela? What's the opposite of dividing by 3?
Multiply.
So I'm going to multiply that x by 3. And here, I added a 2. So what's the opposite of adding 2?
Subtracting.
And think about it. If I wrote this, 3x minus 2 equals 0, you would add 2, and then you would get 3x is equal to 2, and then you would get x is equal to 2/3, which is what that is. Awesome. All right, Edwin. Super hard one. What are my factors going to be?
It's gonna be 2x minus 1.
Awesome. And then what's this one going to be?
Negative 4x.
Well, think about the x though, that 4 is positive. That guy's negative. So instead of dividing by 4, we're going to multiply by what?
By 4.
Now that guy is negative. So
Plus
instead of subtracting, what are we going to do?
Add.
And then the last guy, he's an easy one. What's that going to be? X
Minus.
minus 2, right? If I give you zeros, then hopefully you can come up with factors. Now the last thing, truly is the last thing I want to show you, is about this multiplicity thing. And what happens is that if I show you a function and it's written like this, y equals x minus 2 to the 3rd plus x squared. Well, I know that this 0 happened at 2 and I happened at 3 times. And I know that this is a 0 and it happened twice. And if this was also like this, I would know that 1 would be a 0 and it happened 1 time. Now, what I want you to be also do is be able to see that when you're looking at a graph. And there's 3 very simple rules. First, let's identify the x-intercepts. Emily, what's the x-intercepts on this first one?
-3, 1, and 4.
So x is equal to -3, x is equal to 1, and x is equal to 4. It's easy to find x-intercepts when you're looking at a graph. Now, Emily, the rules are if it goes straight through like a line, then the multiplicity is a 1. Do you see how it's just gone straight through? That gives me a multiplicity of 1. Now, the other possibility is that when it gets to the x-intercept, it bounces off. Do you see here how it bounces off at 2? That's got a multiplicity of 2. So, straight through, that's got a multiplicity of 1. If it bounces off, then it's got a multiplicity of 2. And then the last one is, do you see here where it approaches our x-intercept, but then it flattens out, and then it goes back up again? So we're going to say flattens out. it's got a multiplicity of 3. So Emily, what's this multiplicity going to be for this 1?
1,
And what's this multiplicity going to be for this 4?
1,
And then what's the multiplicity? This x-intercept is clearly a 2. What's the multiplicity going to be?
2,
And this x-intercept is clearly a 4. What's its multiplicity going to be?
3,
Awesome. That's fantastic. One more time. Nia Rankin. So take a look at this graph. First, let's start with the x-intercepts. What are the x-intercepts?
-2, -1, and 1.
-2, -1. Awesome. Now, Nia, what are the multiplicities? First one, it approaches the x-axis and then it bounces off. What's the multiplicity of our x equals -2?
2.
And then in the second one for -1, it approaches the x-axis and it goes straight through. What's its multiplicity?
1.
And then the third one, it approaches the x-axis and then it flattens out and then it comes back down again. What's its multiplicity?
1? Oh,
3. Riley, last one. What are the x-intercepts?
-2, 1, and 3.
So the x-intercepts are -2, 1, 1, and then what are the multiplicities?
For -2, it would be 2. For 1, it would be 1, and then for 3, it'd also be 1.
So if you're looking at an equation, all you got to do is look at the powers, and that'll tell you the powers of the factor, and that'll tell you what the multiplicities are. And if you're looking at graphs, you're looking for straight through, bounce off, or flatten out, and that'll tell you 1, 2, or 3. All right, thank you for that. That was awesome. So check your Canvas calendar to see what kind of stuff you've got to do. Hopefully you're keeping caught up. There's stuff that's all in there. There's actually stuff even in there for 3.5, which we probably haven't talked about. That, I mean, if you want to take a look at it and try to do some of it, if you want to, you can. But at the very least, I think you should be in pretty good shape of doing 3.1, which 3.2, 3.3. Take a look at 3.4 also. There's not very many, like I've knocked it down. There's not so many lessons or the activities to do. And look at the due dates so you know what you got to do. Anyone got any questions for me? All right, then I'm going to let you go. Feel free to hang around if you do have questions. Keep in mind, I'm giving the retake for the test today at 4 o'clock. Otherwise, have a great day.
Where do we turn in the notes?
Oh, there should be an assignment, but you know what? I don't know that there is. Let me see.
There is.
Is there one?
Yeah.
Take a look. I think I put it in that
It's like-
lesson page, and I think it should be like, you should be able to go to the lesson page. It should be the first thing.
It's like 9, 10 note submit or something.
Are we on 3.3?
3.4, I think it's in.
The retake will be a tutoring class, right?
Today, it'll be today. What day is today? Thursday? It's going to be today at 4 o'clock.
Okay.
Use that tutoring, Math 3 tutoring link to get there, okay?
Okay, sure. Thank you so much.
All right, I'll see you later.
Good day.